Hi everyone and welcome back to my channel. This is the second video in the social information network series that I've started. So in the previous video, we've discussed how directed and undirected graphs look and what are the advantages, disadvantages, what are the applications of directed and undirected graphs, how do we write or draw the adjacency matrix for these, and all these things we've discussed. So in today's video, we are going to discuss what weighted graphs are. Okay, so weighted graphs are basically the graphs in which the edges have weights. That is, we understand how important are an edge is. So each edge has a different importance or has a different value. So that is what we will be discussing in today's video. So let us take an example. So this is we have 4 nodes in our graph. This is an undirected graph. Okay, so we have 5 edges in this. Okay, so 1 to 2 is 30, 2, 37, 22 and 5. So basically these are the five edges and their weights that we have here. So now what does this mean? What do these weights mean? So based on the application, these weights may mean different things. So for example, if 1, 2, 3, 4 are locations, the edge weights may mean the distance, the cost that is required to travel from 1 to 2 or anything like that. So wherever each edge should mean different or the importance of each edge is different, in that case, we will be using weighted graphs. So for example, you want to discuss or describe friendships. So maybe 1, 2 are very good friends and that's why they have a high value, and 2, 4 are not that great friends. So that's why they have a lower value of 2. So if you're ranking friendships or giving a score to how close two friends are, this graph may be used to represent that as well. Okay. So in computer science, weighted graphs are extensively used in compilers, and they have lot many applications. Okay. So now moving on, let us understand how the adjacency matrix of a weighted graph looks like. Okay. So let's first write down the edge list. Okay. So vertex 1, vertex 2, weights of the edges. Okay, so we have 1, 2, 30, 1, 3, 5, 2, 3, 22, 2, 4, 2, and 3, 4, 37. So this is how the edge weight or the edges with their weights, the table looks like. So you can call this your edge list. Okay. So in the previous video, we've seen that when we're writing the adjacency matrix of the weighted graphs. So why do we write the adjacency matrix once again? We write the adjacency matrix because we want to represent the graph mathematically so that we can use it in computer programming, we can use for calculations that are further required. Okay. So adjacency matrix, how will the adjacency matrix of a weighted graph look like? So in an unweighted graph, if there was an edge between two nodes, we used to consider it to be 1, right? So what that actually meant was that the weight of that edge is 1. So that is why wherever there was an edge in the table, we used to fill 1, and wherever there was no edge, we used to fill 0. So wherever there is no edge, that will be the same in weighted graphs as well. But the difference is wherever there is an edge, instead of writing 1, we write its weight, showing the importance or showing the value of that edge. Okay, so let's say V, and we have 1, 2, 3, 4, 1, 2, 3, 4. Because this is an undirected graph, we give hyphens here, and which means that there's no value there. And 1 to 2 is 30. If there was no edge between 1 to 2, we would have written 0. Okay, and 1 to 3 it is 5. This and this is done. 2 to 3 it is 22. 2 to 3 is 22. 2 to 4 is 2, right? 3 to 4 is 37, and the rest all are zeros. Okay. Now we've discussed one important thing in the previous video, which is that the adjacency matrix of a undirected graph is always symmetrical. So based on this, we can fill in the rest of the values, right? Because it needs to be symmetrical, right? Okay, I'm sorry. Okay, so we need to just because we know that it is going to be symmetrical, we just are going to write down the values from before, from the first half of the adjacency matrix. So this is how you draw the or you make the adjacency matrix for a weighted graph. So what we have discussed basically is that in when the graph has no weights, it's not a weighted graph. The edges have the value, or the edges have a weight of 1 or 0. So it's either if the edge is there, it is 1, if the edge is not there, it is 0. But if it's a weighted graph, each edge has a weight which represents some characteristic, that is some characteristic of the graph or of the feature or application that the graph is representing. This each edge weight will have some meaning when we look at an application. Okay, so that's all I had for this video. Thank you for watching, and if you learned something from my video, do like, share and subscribe. In the next video, we will be discussing about ego networks and whole networks, what the difference between them is and how they work. Okay, so stay tuned for the next video and I will meet you soon. Thank you for watching.